Welcome. We've got video number 3. So today is all about functional notation. Our goal for today, you will be able to use functional notation to find missing values. You will do this by using substitution. All right, so let's go ahead and take a look at what functional notation really is. So here we go. Functional notation is a special notation used only for functions. Okay, so we are used to seeing linear equations, so our lines, in the form of y equals 2x plus 3. What functional notation is going to do is it's going to take the y and it's going to make it f of x, or g of x, or h of x. So that's stating that it is a function, so you can use any letter there. So it's just replacing the y with this functional notation. So these are all examples of linear functions. We can also do this with quadratic equations where your x is being squared. We can take the y and we replace it with one of our functions. Now the one thing I do want you to notice here is that the letter inside of the parentheses is the variable that's being used in the equation. So f of x equals 2x plus 3. G of x equals 2x plus 3. But if you look at this last one, it's h of a is equal to 2a plus 3. So we have whatever variable is in the parentheses, that's the variable in the equation. So notice y is simply replaced by f of x, g of x, and h of a. This is known as function notation, and they all mean exactly the same thing. But with function notation, it's actually a way of asking you to find missing values. So let's go ahead and take a look at how that's going to be done. So if we take a look at our first example here, it says if f of x equals 3x minus 6, we want to find f of negative 3. So if we take a look here of f of x, we notice that this is an x and this is an x. So if I take a look here now, instead of an x, now we have a negative 3. So I'm going to come below here. So f of negative 3 is equal to, now I'm going to start by writing my equation 3. But instead of putting an x, I'm going to substitute in a negative 3. And then minus 6. So I'm just rewriting the whole equation, but instead of an x, I'm substituting in a negative 3. And now I can let my calculator do the handy-dandy work for me. So 3 parentheses negative 3 minus 6, enter, and we get negative 15. So f of negative 3 equals negative 15. Okay, now let's try the second one, f of 2. So now, instead of an x in the parentheses, we have a 2. So I'm going to rewrite my equation, but wherever I see an x, I'm going to substitute in a 2. So this is going to be 3 times 2 minus 6. Okay, and now let's go ahead and plug it in. So 3 parentheses 2 minus 6. So f of 2 is equal to 0. And we've got it. All right, now let's take a look at number 2 because it's slightly different. So if h of x equals 2x minus 5, find the value of x if h of x is equal to 11. So this time, I do not know what is inside the parentheses. So I'm going to keep the x in x because there's still an x there. But this time, I want to find x, and they're telling me that the whole thing is equal to 11. So in this case, if h of x is equal to 2x minus 5. They just told me here that h of x is equal to 11, so I'm going to replace h of x with 11. So I'm going to take this 11, and it goes here. So this whole thing becomes 11 equals 2x minus 5. And now we have to solve for x. So I'm going to go plus 5 plus 5. So 16 is equal to 2x. Divide both sides by 2, and we get x to be equal to 8. And we were able to find x. Okay, let's take a look at another one. So if g of x is equal to negative 2x plus 7, find the value of x if g of x is equal to negative 1. Now there's still an x inside of my parentheses, so I'm not replacing the x. Okay, I am going to instead just rewrite the whole equation. Now they told me g of x is equal to negative 1, so I'm going to substitute negative 1 for the g of x. So this whole thing is getting replaced. So negative 1 is equal to negative 2x plus 7. And now we're going to solve for x. So I'm going to go ahead and subtract 7. So I get negative 8 is equal to negative 2x. And now I'm going to divide both sides by negative 2. And we get x is equal to, so a negative divided by a negative is a positive 4. Okay, let's go ahead now and let's try one more of each. So if I take a look at number 4, if m of x is equal to x squared minus 4x, find m of negative 2. So now the negative 2, that is where the x is supposed to go. So that means I'm going to replace my x's with the negative 2. So m of negative 2 is equal to negative 2 in parentheses squared. Remember, when you use substitution, it has to go into parentheses, minus 4 times negative 2. Okay, and now we can use our handy dandy calculators to figure that out. So parentheses, negative 2 parentheses squared minus 4 parentheses negative 2. So the whole thing is equal to 12. Now, if I wanted to write this in terms of x's and y's, I know my x value is equal to negative 2. Okay, so x here is going to be equal to negative 2. Now remember, m of x is a fancy way of writing. So m of x, or whatever letter, is, notice the y is replaced. So f of x, g of x, in this case m of x, is just a fancy way of writing y. So my y is equal to, so this whole thing is just y is equal to 12. Okay, and that's all that functional notation means. All right, let's go ahead and try number 5 now. F of x is equal to 5x plus 1. Find the value of x if f of x is equal to 31. So this time I do not know the value of x, but I know this whole thing is equal to 31. So I'm going to start by writing my function. And this time, instead of replacing the x, because it's still f of x, I'm going to take 31 and I'm going to substitute it in for the entire f of x. So you have to be very careful to see if the number is in the parentheses or if that's what it's equal to. All right, and now we're going to solve for x. So we subtract, we get 30 is equal to 5x. Divide by 5, so x is equal to 6. So if x is equal to 6, well then what was my y equal to? Well, remember, f of x is a fancy way of saying y, so y is equal to 31. All right, and we've got it. All right, let's go ahead, flip it over, and try a couple different types of examples. So, number 5. If f of x equals 3 times parentheses x plus 4, find the value of f of 3 minus f of negative 2, all divided by 3. Ooh, so we've got quite a few things going on here. So the first thing I have to do is find the value of f of 3. Then I have to find the value of f of 2. And then I got to put it all into that fraction. Okay, so let's go and do one step at a time. So step 1, let's find f of 3. Okay, so f of 3. Now the 3 is where my x is supposed to be, so that means I'm going to replace or substitute in a 3 for my x plus 4. Okay, and let's go ahead and take a look. So 3 parentheses, 3 plus 4, and we get 21. Okay, next I need to find f of negative 2. So once again, my negative 2 is where my x is supposed to be. So that means I'm going to replace my x with a negative 2. And once again, I can let the calculator do the work for me. So 3 times negative 2 plus 4. And we get 6. Okay, so now that I know what f of 3 and f of negative 2 are, I can replace it in my parentheses. So this is actually going to change. So instead of f of 3, I know that value is 21, minus f of negative 2 is 6, all over 3. Okay, the first thing I have to do is combine my numerator. So 21 minus 6, and we're going to get 15. And then all over 3, and then 15 divided by 3 is 5. So 5 is our final answer. Okay, let's take a look now at number 6. All right, the graph of y equals f of x is shown below. Which point could be used to find f of 2? Okay, so here we need to think very carefully. There's a 2 inside of the parentheses, so you need to think. Inside of the parentheses, is that your x or your y? All right, well, if I take a look here, x goes inside of the parentheses, so that's going to be my x value. So what we're going to do is go to the x-axis, look carefully for positive 2. So if I take a look, positive 1, positive 2. So what point is right there? Point A. So point A is f of 2. So let's go ahead and let's do a star question. Which point could be used for f of negative 2? So go ahead, take a moment. I'm going to have you pause the video and look carefully at a graph. So which point could be used for f of negative 2? And the answer here is C. So remember, the number in the parenthesis represents the x. So our x is negative 2. So we go to negative 2, and there is C. Okay, last question for today. Let f be a function such that f of x equals 3x minus 2 is defined on the domain of negative 1 is less than or equal to x, which is less than or equal to 3. Find the range of the function. Okay, so here we're using some of our vocabulary from the other day. So remember, domain are your x values, and we want to find the range, which is going to be our y values. So if we wanted to set up a table of values, so we want our domain, which is our x's, and our range is our y's. So our domain is going to go from negative 1 all the way up to 3. And our range, well, that's what we have to find. So to find the range, we're going to use our function. Okay, so the first one we're going to do is f, our first x is negative 1. So we're going to go ahead and plug this in. So 3 times negative 1 minus 2. Let's go ahead and check it out. So 3 times negative 1 minus 2. And we're going to get negative 5. So my first range is negative 5. Now to find the second one, now I'm going to input a 0. So 3 times 0 minus 2 is equal to, so 3 times 0 is 0, minus 2, negative 2. So my next one is negative 2. Then I'm going to go ahead now, find f of 1, f of 2, f of 3, and I'd like you to find these on your own. All right, so if we plugged those in, we should get 147. We fill in the rest of our table of values. 147. And now we have finished our